presentation. It's my pleasure to invite for this presentation our long-time industrial partners. Dear colleagues, do you hear me?
Yes, yeah.
Thank you. It's Infineon, a company Infineon. Our today presenters, Dr. Alexander Karpin, Dr. company which had quarters in Germany. Alexander has 20 years of industry and academic experience in algorithm, embedded system solution, and so on. His research interests include human-machine interaction and interfaces, biometrics, sensors, IoT, wireless connectivity, artificial intelligence for embedded systems. Alexander has 68 United States patents. And Dr. Orest Akimishin received PhD in the same university, Lviv Polytechnical National University. He is currently a principal system engineer at Infineon Technologies. Orest has 15 years of industry experience in embedded system solution, hardware, software co-design, and firmware development. His research interests include IoT, firmware development methodology, security, and embedded solution. It's my pleasure to invite Alexander and Orest for your presentation. Thank you for your contribution for this conference. Welcome.
Okay, thank you, Vyacheslava. It's a pleasure for us to be here and present our company. I'm sharing our slides. Okay.
Yes, we see your presentation. Maybe full screen you can make.
I just made full screen. Should
Okay.
be okay. Our topic today is connected secure smart sensors, and from the title of presentation you can see that we will talk briefly about some introduction and the state-of-the-art technology in sensors, wireless connectivity, smart system in embedded security. Before we will talk and move on to the technical stuff, a few words about us. So we represent Infineon Technology Company, German-based company, multinational, and that have office in Lviv, Ukraine. And key topics for the company is decarbonization. It's actually like our social responsibility also to save CO2, energy efficiency, and sustainability. And the second big topic is digitalization. It's to improve our productivity, comfort, create new use cases, and make our life better and easier. So from financial standpoint, you can see that company is rapidly growing. Maybe the last 5 years, it's grew up by 2x. And in the company, we have different divisions: one automotive, industrial power control, power sensor system, and connected secure systems. And Infineon, just to add some scale, Infineon is a global player in semiconductors, at clearly #1 in power semiconductors in the world, and #4 in overall microcontroller market. Okay. So let's today we would like to talk more about smart home solutions. And it's a nice picture that represent all different smart devices that we should have in our home, but not sure if actually today we have something like that. And we will present how industry address this problem. You can see. Okay. Do you see still first slide? Yeah. Once more, I will share. Sorry. Once more. Okay. Can you see slides?
Yes, absolutely okay.
Okay, have you seen this third slide or fourth? Or it
Yes,
was
yes, all okay.
Okay. So I'm not sure if I go to presentation mode. Let's Okay, so we will present smart home solution and how industry address this problem today, and how we believe and why we believe that in the near future we will have revolution in our smart home systems. So in general, you can see that if we talk about smart home or general IoT devices, it can be represented by this simple block diagram, despite is it which kind of device it is. On the left side, you can see it's like different kind of sensors. In the right, it's like response or power part. Also, we need to have connectivity, a microcontroller to implement smart functionality, and very important part also to have a trust to the device, it's security. Let's talk about sensors, how we represent and have from the sensor standpoint. The first, if any electrical engineer consider sensors, it's usually sensor, it's like capacitance, inductive, resistance, current, voltage on the output. It's some device that have these characteristics. And for example, few examples. If you talk about capacitive sensor, it could be capacitive button, trackpad, liquid level, proximity sensors. Or if we talk about sensors that have current on the output, it could be PIR sensor for motion or presence detection, or it could be ambient light sensor to detect day or night, or maybe optical proximity sensor to detect some gestures, and so on. There are a variety of different sensors. And you can imagine all these complexities that engineers to work with all these kind of sensor, having microcontrollers, they need to have special blocks to operate with all of that. So in Infineon, we presented, like if you see programmable system on chip, then we have one block that we called multi-sense converter, that just one block can connect to mostly all these sensors, and having analog bus and allows us to connect to one chip all these kind of sensors. So how many pins do you have on your microcontrollers? So many sensors you can connect and operate. So it's the first, let's say, revolution in all these sensors. The second, that we start considering sensor not just like physical device, but devices that simulate human senses. For example, smart feel, smart eye, smart nose, smart ears. Okay, I will stop sharing for some reason. People saying that they don't see all my slides. Have you seen these slides before, 9, 10, 11? Sorry for that. I'm not sure what's going on.
Yes, we see the slides.
Okay, good. That means that just for one colleague, they can see. I will present not in presentation mode, but in this slide. But it's very important that from sensor standpoint, you can see that.
I'm sorry, just one moment, Alexander. Yeah. Now we can't see your slides.
Can't see now.
Yeah, before it was good. Now nothing.
Okay. But now it's okay, yeah?
Still no.
No, I can't see it.
Share. I can share desktop, but just can share a window, and for some reason, okay. Now
Yeah,
should
okay.
be okay. Yeah, okay. Let's try move on. So the first very important message that or revolution through sensors, that all this complexity of the sensor can be done in one block. So for electrical engineer or system engineer, they can use just one multi-sense converter to connect to all these different variety of sensors. Having analog bus and microcontroller, you can connect all these sensors to the one pin and use sensor fusion, processing, and all this good stuff. The second revolution, we can say that we consider sensors as as human senses, like smart fields, smart eyes, nose, smart ears. And let's see some example. For example, smart nose, it's like CO2 concentration sensor. So we developed this sensor, and we put like in our experiments together with a high accuracy reference CO2 meter that cost $1,500 bucks, and we see that it's quite good correlation. Very tiny, low cost, cheap device, and very high expensive gives mostly the same accuracy. But the question, why we need to measure this CO2 concentration in our real life? Why we need this smart nose? For example, research indicates that the impact of CO2 on human decision is dramatic. For example, we have today the conference, and I am happy that I am presenting in the morning, but if it's real life conference, and in the end of the day, we see in the meeting the CO2 level usually increased to some level concentration like 2000, but we can see if information utilization, if CO2 level is like about 2000 ppm, we just mostly students or attendees mostly dysfunctional. It's not because it's end of the day, we are tired, but just because of CO2, we create environments that our students, our attendees are mostly dysfunctional. And this is very, very important. And how this you can ask how we can make this sensor so cheap, so small. But if you see, we are using photoacoustic sensor principle. So we have the simple LED, optical filter, and that's all. And we put our microphones inside the, let's say, box.
Can't hear.
Maybe the problems with internet.
Can you hear, Oleg?
Yeah, I can hear you.
Maybe problem with internet from Alexander's side.
Yeah. Okay, I am back. It was power supply drop, so sorry. Okay. Next time I will travel. Okay, can you see my screen?
Yes.
Yes.
Yeah. And
Yes.
as I finished, the innovation is very simple. You can see very low cost infrared optical filter, state-of-the-art microphones that we have in any mobile phone. And as a result, molecules of CO2 resonate at some frequency of light that we are controlling by optical filter, and microphone can measure the pressure. And as a result, we can see the CO2 concentration. It's very low cost, very small, and as a result, we can address lots of different applications in in smart home devices. Like we just when apply CO2 sensor for ventilation control for we can save energy by 30%. It's a huge savings, and also we can improve productivity, comfort, make healthier our life. The second sensor, it's like smart eye, like time of flight technology. From block diagram, you can see it's quite sophisticated circuit. The same, we need to have infrared modulated car light. Next, we need to have lens, pixel of matrix. We need to have some processing, ADC converter, but in the end, we are getting depth and amplitude of signal. And it's quite complicated circuit by doing special modulation system. We were able to create this sensor very small. You can see for the $250, it's very small and very low cost. And the same. If we apply, I will try once more to go to presentation mode. Okay. If we try to apply this technology for consumer application, it's variety of application. It's like user-facing, world-facing, consumer robotics, argument, virtual reality. We can address a lot of challenges that we are having today. The second smart eye, it's also very sophisticated, like radar technology. So if we talk about radar technology, we can imagine something very big that is used for tracking aircrafts in the military. But also recently we heard about autonomous vehicle and usage of the radar in automotive, but they still, we believe, some kind of expensive. But maybe not know if everyone knows that Infineon like introduced and developed radar technology for consumer. And you can see the same very tiny devices that we have in industry today that can address lots of application for consumer. Like radar technology today, if you put in smart home, can recognize each person in the room. And you can imagine which devices could be created, like occupancy-based hinted ventilation device on off, directional audio effects on individuals. But our sensor is so sophisticated that they can recognize and monitor sleep signal also, and monitor the quality of sleep, and also can recognize vital and do vital sensing, like for the elderly, very important, or for the fitness. And okay, we have all this sophisticated sensor. Is it enough to create like smart home devices? That's no. And when all these companies today start talking about smart home devices, that the next level, they should be connected. And how they can pick which physical protocols they should use. Is it Wi-Fi, Bluetooth, maybe G5, LoRa? All this very complicated. The second level complexity, they need to develop their own protocols, next software, and you can imagine it's already the team of 500 people and more. And if small startups is willing to create some device or anything, it's mostly impossible. And this prevents this growing of smart home devices, maybe for all these 10 years that we heard recently about this revolution and IoT and something. But just 2 months ago, it was released Matter standard. So what is about? So it's several years ago, the companies, very big companies, including Infineon Technology, 280 plus companies and many individuals came together and created Connectivity Standards Alliance to address IoT needs for smart devices. And actually, it's very simple idea. They created like protocols that all devices should communicate through IP protocol, very well known, and they created open source libraries for all devices to communicate with each other. So despite what you do, for example, just startup company or small company decided to create smart light, they don't need to create all this software ecosystem, and as a result, they were not competitive with big manufacturers. But today, consumer can pick any device that is compatible with Matter and be sure that all their ecosystem will operate in smart home devices. And we believe this will be a revolution for the future of in smart home, and this is great example how industry addressed some problem to make let's say our consumer life easier and better. And the third big component today is neural networks or smart operation microcontroller. And just to mention that microcontrollers today also are quite sophisticated, that you can run on the edge some neural networks functionality, and as a result, device become even more useful for the end user. So you can see sophisticated sensors, great wireless communication plus smart operation. This is what we consider is IoT, but that's not everything. There is also very important next part that will be presented by Orest, and at this point I hand over to Orest. Orest, please share.
Thanks, Alexander.
Welcome, Orest.
It's the first time for us to be here, so it's a nice